Surface modeling is a technique used in computer-aided design, CAD, and computer graphics to create complex, smooth surfaces. It involves the mathematical representation of a surface within a three-dimensional space, allowing for the precise manipulation and visualization of objects. This technique is crucial in various fields, including automotive design, aerospace engineering, architecture, and animation. There are several methods of surface modeling, each suited to different types of applications. One of the most common is NURBS, non-uniform rational B-splines, which provides great flexibility and precision. NURBS can represent both standard geometric shapes, like planes and cylinders, and freeform shapes, like car bodies and aircraft fuselages. They are defined by control points, weights, and not vectors, allowing designers to create smooth and intricate surfaces that can be easily modified by adjusting these parameters. Another popular method is polygonal modeling, which approximates surfaces using a mesh of polygons, typically triangles or quadrilaterals. This method is widely used in computer graphics, especially in gaming and animation, due to its simplicity and efficiency in rendering. The level of detail can be increased by subdividing the polygons, a process known as tessellation, which allows for highly detailed models. Subdivision surfaces are another technique that combines aspects of both NURBS and polygonal modeling. Starting with a coarse polygonal mesh, this method applies a refinement process to produce a smooth surface. Subdivision surfaces are particularly useful in character modeling and animation, as they can create smooth, organic shapes with relatively simple initial meshes. In addition to these methods, implicit surface modeling uses mathematical functions to define surfaces. These functions can represent complex shapes and are particularly useful for simulating natural phenomena, such as fluid dynamics or soft tissue deformation. Surface modeling plays a crucial role in the design and visualization process, providing the tools needed to create accurate and aesthetically pleasing models. Advances in computational power and algorithms continue to expand the capabilities and applications of surface modeling, making it an indispensable tool in modern design and engineering.